to talk to you about what happens when the entire public web is in your agent's context. And I want to set the stage by talking about an evolution that we have seen in the last 20 years of the process of search and discovery. There's almost like a roadmap we can follow from index-based search to chatbot QA to RAG-based search and ultimately to agentic search. And let me just walk you through it now. The story, of course, begins with something that we're all familiar with, the classical Google search from 10 years ago, 15 years ago. This really taught us how to do search, where whenever you're looking for some information, what we asked humans for were keywords. We made humans talk in almost machine language, as Angelina was alluding to, not code, but keywords, because that's what we could implement and handle at the time. The output in these scenarios are typically 10 blue links. You get a snippet, maybe. And the way this is done in the back end is that search engines such as Google maintain a index of web pages and are crawling web pages and at certain frequency and ranking them based on relevance to your keywords. The problem with this, of course, is that this is slow. There's a lot of cognitive overhead in consuming this information, because what you really want to do is ask a question and get an answer, but what you get back are links which may or may not contain the information that you're looking for. The next evolution for this came really as a breakthrough of AI. Think about the first version of ChatGPT 2022. This is before the integration of search APIs inside chatbots. And that really flipped this model on its head, where the input became natural language questions. Just ask what you want to know about the world. Don't try to write in keywords. And the output is not 10 blue links, it's answers. And so it's really QA. Um, the how, of course, was completely different. This was retraining on web data. The AI model companies went out, got access to web data, pre-trained their models, post-trained them for being chatbots, and so then you could talk to it. The problem, of course, is that this data isn't live. There's the knowledge cutoff, and so you can't ask about anything that happens after it. You notice that you didn't have to fit the entire web in the context. The web was fit in the parameters of the AI system that you're talking to, and of course, that's why it can lead to hallucinations, because it's not grounded in anything. Um, the next step, of course, here was to combine both of these two ideas, take the best of both worlds. And this is what led to early efforts in RAG-based search. Think about the first version of Perplexity, and now Perplexity has matured into other offerings as well. But the idea here was the input stays the same. We still want the benefit of asking natural language questions. We don't want to type in keywords. The output is synthesized answers. It's not 10 blue links, but this time it's a front end that is your agent is making calls to a web search, reading the 10 blue links or the snippets and synthesizing an answer. So it's almost an AI front end for web search, if you will. And this made it nicer, but the problem here was that this was brittle to the phrasing of your question. If you didn't use the right if you didn't provide enough context in your questions, the search query was one shot, and so the results really mattered, and it really depended on what kinds of queries you formulated. The next step in this evolution is, of course, agentic search, where your agents can do dynamic tool calling. This is what, for example, products like Google's Deep Research incorporated, and now every single AI product has Deep Research, where the input is questions, the output are synthesized answers or reports. And the way it's done is that the model is running tool calls plus arguments in a for loop, and it's executing those tool calls and giving you that final answer, synthesizing everything. I claim that this is not the end of the journey. The next step is actually a for loop around this process, which is monitoring or cron job. And here you would give an input query, again, natural language. An output would be a periodic report, not just an answer. And it's really agentic search in a cron job, which is intelligently scheduled. To give you an example, this is what we build at Tutori. This is called a Scout. So if you're looking to buy a monitor and when the prices drop below 1000, this is now a monitor that is running against the live web. It is constantly searching, and whenever that event happens that you described in natural language, it sends you an email so that you can, for example, go buy that item that you're looking for. Behind the scenes, it's agentic search in a cron job. And so this is what that agentic search loosely looks like. In this case, the person had asked for a certain apartment with a certain set of constraints that are close to certain destinations that they're locations that they're looking at. And so behind the scenes, a team of agents are going and trying to gather that information. There are sub agents and tools, and this entire process is run at some frequency every hour, every day, or so on. And so that you get a result that says, okay, you had asked for houses, condos, apartments with at least one bedroom for rent, 550 square feet in Seattle's this neighborhood that allows blah, blah, blah. And the agents went out and finally gave a report that says, I found a new option that fits your parameter. And it's a new option. We have not told you about this before. So, and the idea is that you want this as a front end for the web that you can ask anything. AI agents, startups announcing new funding on TechCrunch, some product that you're monitoring whenever it falls below a certain price threshold. Um, Posts on Reddit, subreddits about new offices opening. Anything that you can think of is the goal here. And in order to do this, you should think of this as three layers of a for loop. An LLM sampling layer is the first layer of the for loop. Taking actions or tool calling, the agent layer is the second layer of the for loop. And a scouting or a monitoring layer is the third layer of the for loop. And so this is quite expensive. And as such, there are some really unique challenges here. Fitting the entire web into your context is just not going to happen. There are heterogeneous set of tools that your agents has access to. Some web services have APIs. The long fat tail of the web does not. So how do you access that information? And this is extremely long horizon. The scouts run for months. Um, and so I'll tell you some ideas that we have explored with, and of course, I will refer you to details at other places. So for one, it's just hopeless. With regardless of how much context windows for the models increase, we're not going to fit the entire web in the context. And so what we have to do is orchestrate our agent into sub agents. And so that's what this illustration is showing. There is a orchestrator at the top that's calling sub agents that are doing their job. This leads to context management. The context windows of the two sub agents are separate. It doesn't explode. There's separation of concerns. The sub agents can prioritize recall, whereas the orchestrator, the root level agent, can prioritize precision, so that because that's the one that's communicating with a human. So, for example, if you're asking, are there any tickets available for the show in San Francisco? The sub agents can go scour lots of websites, but the top level agent can decide when it trusts some information. Um, and of course, you can manage intelligent at costs. Like certain subagents can be specialized, so they're cheaper. Here's an example of that. If the query is summarize any new interviews from Mark Andreessen, Naval Ravikant, and DHH, this can be farmed out into subagents. Some of them are looking at web search. Some of them are looking at Reddit search. Had we shoved all of these tools and their outputs into a single agent, that would pollute the context very quickly, and the root level agent wouldn't be able to absorb the entire context. Notice that some summaries and interviews require web pages to be read. And so there's an agent that will go read those web pages so that you get this final report that says, okay, here's the 2026 AI outlook out of this interview. You had asked for any new interviews. Here's what happened on this date. Mark Andreessen gave this interview. Here are the key topics covered, and here are the notable timings and things. The other interesting thing that this sub-agent architecture does is that it allows you to do query enrichment. The user will typically want to save as few things as possible because it's a lot of work to explain everything that I want. I want you to just understand what I'm talking about. And so the user will say something like monitor developments on computer and browser use models. but the orchestrator is expanding that query before it sends it to the subagents. It says, search for recent technical blogs. The user never said technical blogs, but the orchestrator inserted it. The user never said, only include information published after December 12th. The orchestrator inserted it because it knows it wants something recent. The orchestrator is saying things about Google search with date filters, archive, median, dev.to, company blogs. This is all information that models are inserting that the user doesn't have to. The second thing that I want to tell you about is that some web services have APIs, for example, web search. The fat tail of the web does not. And for this, you just have to operate a browser like a human would. So what I'm showing you on screen here is a browser use model that we train at Utori ourselves that takes as input a screenshot of the browser and predicts human-like actions, click, type, and so on. And this unlocks the long tail of the web. This model is called N1, and the agent is called Navigator. It's named after Netscape Navigator from the 90s, which really was the first browser. Um, and as I mentioned, the input is a screenshot, the output is a human-like operation. And so anything that a human can do, this agent can automate. What I'm also showing here is uh, an extension, a Chrome extension, where a user can directly ask for questions and operations in their browser, but the agent can also operate in the background. Doesn't have to operate on the user's browser. We've benchmarked this agent and this model quite thoroughly. We're actually quite proud that it matches and outperforms some of the most recent, pre Opus 4.5 models on standard benchmarks while being faster. It actually matches the performance of Opus 4.6 while being significantly faster and cheaper. Um, well, there's a lot of work that's gone into training the model, and it has experience and it has been trained on live websites. And so it learns from interaction and reinforcement learning. And this is really what unlocks the long tail of the web. And finally, the last idea that I'll leave you with is that scouts run for months. I actually have monitoring queries running since June of last year. So since 2025 June, I've had a query running on a certain topic. I'll leave a URL on the slides. But when you have a monitoring query that is going out into the world every day, you're not just fitting the entire web into the context, you're fitting the web evolving over a year into the context. And over time, the concept drifts. And in order to deal with that, you have to build a product design that allows people to give feedback to their agents. And that's something that we've put in a lot of work in. And that when you get a report back, you can actually respond to your agent. And what it does is for all future reports, it will keep those feedback guidelines in mind. There are some ideas and challenges that I'll mention only briefly, but I'll give you pointers too. Um, as I mentioned, there are lots of heterogeneous tools here. A web search happens in milliseconds. It's quite accurate. APIs are actually quite accurate. Navigating with a browser is sometimes 1,000x slower, but it unlocks a large part of the web that is closed off to API-based models, to search-based models. Some APIs return comprehensive metadata, others return just a link and a snippet. And so really there's a lot of like management of these heterogeneous tools that you have to do if you want your subagents to work well. Um, Ultimately, there are long challenges of reliability anytime you're dealing with the public web. APIs fail, browsers die, agents are misclassified as bots. How do you keep going? Um, there is a one of a kind reinforcement learning problem here. This is technically known as asynchronous distributed multimodal RL with heterogeneous actions. I won't bother you with those details here, but we actually have some details on in a blog that I'll point you to. And of course, learning from trial and error is quite risky. When right actions have sharp consequences. Um, and if you're looking for details on these things, here are pointers to blogs that contain a lot more information, and you'll have my slides to go read these offline.